For this video, you need to be on the notebook page called Video Motion Analysis that looks like this on the screen. And there's a chart, and what we're trying to do is figure out gravity. Like, what is gravity? It's, we know that when we drop a ball, it's going to land on the ground, and then it's dropping at some speed, but is it speed or acceleration? So we started talking about that. We dropped a ball, and we dropped it around to the ground and watching it. We said, well, we can't figure this out by just watching it. So we talked about the difference between speed and acceleration. And we said speed is when you're traveling at a constant rate, like 35 miles per hour on the road, whereas acceleration is I move from one speed to the next speed in a certain amount of time. So I go from 35 to 40. I put on the gas and I go up to 40 miles per hour in a couple seconds or something. And then if I slow down even, that's acceleration. That's negative acceleration, but it's acceleration. So anyway, so on this chart, you're going to see the first three columns is what we're going to fill in right now. Because we took a video of the ball falling, and that's what these frame numbers are in this column. There's going to be frames that we're going to start with of this video. It's in super slow-mo, and there's like snapshots. And then in each frame, the ball will have dropped in a certain time. It's going to have some kind of time. And then the X, or the position, remember X marks the spot. So the position of the ball will be some centimeters down from zero because it's dropping. So those are only the first three columns that we're going to worry about right now. We'll worry about the rest later. So now I'm going to show you what we did in class. That's not the right video or the right slideshow. All right, so here's frame one. Okay. If I can get this to come down a little bit. Okay. So frame one, the ball's at zero up top. You can see it's up at zero. And we're going to look and see when it drops. So X marks the spot. There's the ball. Look at frame one down here. Okay, now I'm going to go to frame two, see if the ball drops. See if you notice when the ball drops. There's frame two, frame three, frame four, frame five, frame six. Okay, and you should see that it moved on frame six. Okay, so we're going to go back to frame five. That is going to be going back to frame five. So on your chart, we're going to put on the first row, frame 5, time, see how it says 0.13333? We're going to round to the nearest hundredth. So 0.133, that third 3, or that third number is the thousandths place. Well, that means, since it's lower than 5, that 3 stays the same. So on your time chart, you should write 0.13. And then position, well, it hasn't moved from 0 yet. No, we know it's getting ready to, so under position, or X, you need to write 0. So let's go to frame 6. What are we going to write on that line? Well, time is now 0.167, so 0.167 with rounding. We're on frame 6, and you'll notice when we get down here, we know it moved. Here is our centimeter. So again, frame 6, time 1.67. We need to do some rounding here. How far is the ball moved? That little line up here matches with the centimeters down here, which is 0.60. Here's frame 7. Again, this line up here is getting a little bit longer, so that makes this. So the ball's falling a little bit longer, so write that information down. Round to the nearest hundredth from frame 7. Here is frame 8. The ball has dropped a little bit further. It's now dropped almost 3 centimeters. Here is frame 9. Frame 10, here's our balls dropping, dropping, dropping. Frame 11, you notice here, is the ball dropping in a straight line now in frame 12? No. So keep that in mind. The ball didn't really fall in a very straight line. It kind of moved over a little bit. That might have made some error. Frame 13, and remember, we're trying to measure distance by seeing the center of the ball. They're approximating this, so there's going to be some error here. We cannot even tell where the center of the ball is right now. We're guessing. Here's frame 14. Okay, here it's almost to the bottom, and so there's going to be some error. We're not going to get perfectly whatnot, but we need to figure out if this gravity is speeding up, staying the same speed, or speeding, what is it doing? And then frame 15. Well, wait a minute, we're at the bottom. So if we're at the bottom, is the ball any longer falling? No. So we're going to stop. Okay. We're not going to use frame 15 and 16, okay? We're going to stop. I'm not even going to use frame 15. Okay, we're going to stop at frame 14. So now I'm going to go out of this, and I want to make sure you got what you should have gotten on your spreadsheet. So check your spreadsheet. You should have gotten these values. All right, so now I want you to get your calculator out. We've got the data, and here this delta t means change in, oh, this is going to let me do this, time. Okay, you can see it saying it right here, change in time. All right, so then delta x, so that delta, that triangle just means change, and change means subtract. Okay, so let's do that column, change in time. So how do we do that? Well, we're at 0.13. Can we have any change in time? So no, we put like a dash there or something. Oops. You don't put anything in there for now. Just X it out or leave it there. So that means any of these changes, anything for the rest is not going to have anything. Okay, so that's change in time. What about this delta x? Well, we just said delta means change and x is position. So delta x can be change in position. So write that down. Delta x can be change in position. Okay, change in position. Remember, x is position. So what is v? V is either velocity or speed. Delta v again means change or subtract, so that's going to be change in velocity or speed. And then a is in centimeters per second squared, that's acceleration. And then the only difference to this one is it's still a, which is acceleration, but instead of doing centimeters, we wanted to change it to meters, but don't worry about that right now. Okay, so to get change of t, up here again, we said we can't put anything here. We're going to leave that blank. You can't have any change. So just leave that line blank. Let's go to line 6. If I want change in t, I'm going to go to my t column. Well, in frame 6 is 0.17 minus frame above it, 0.13. You should get 0.04. Okay? And then you're going to continue on that column. And so here, if you get to 7, you're going to do, I think it's 0.2. You're going to go up a column to 0.17. You should get, I think it's like 0.03, something like that. So continue to do that. All right. And I'll do one more. I think the next one, if you do 0.23 and 0.2, it's 0.03. All right. But continue to do that. Then when you're done, come back to this column. All right. Now we're going to do change in position. So we're going to do that same thing, but now we're going to look at this column. So change in position, 0.6 minus 0 obviously is 0.6. 0.84 minus 0.6, remember you go frame above, it's 0.24. Okay, then you come over here, 2.87 minus 0.84, because you got to go a frame above, is I think 2.03, something like that. Okay, finish that column. Now we want speed. What is the equation of speed? Well, for speed, you want distance divided by time. So you need this column, delta x, right? Because you need how fast something's going, or how much the distance is, and how quickly it did it. So we're going to do delta x, distance, divided by the change in time. So for speed, we're going to do 0.6 divided by 0.04. And when you do that, what do you get? Okay, so I want you to go through, do that dividing, 0.6, so it'll be 0.6 divided by 0.04. Oh, of course it doesn't like that. Sorry, I didn't put the equal sign. Okay, 15. And then if you did 0.24 divided by 0.03, oops, I forgot to do the equal sign again. Remember, distance divided by time. You get 8, and I'll do one more. So equals 2.03, distance divided by time, 0.03. Okay, so this is our speed. So in each one of those frames, this is our speed. Well, now I want the change in speed because I want to get into acceleration. So my change in speed, again, is, can we go up here, 15 take away nothing? I mean, that something doesn't exist? No, so we're going to skip that one. So if I'm going to do 8 minus 15, yes, we can do negatives. That's going to be -7. If you do 67, so equals 67.67 minus 8, you get 59.7, and so on and so forth. So finish that column. Okay, now we're doing acceleration. So now acceleration, what's the What's going to be our formula for that? Well, acceleration is the change in velocity in a given time. So we're going to do another division, just like we did for velocity, but now it's going to be a little different for acceleration. We're going to do change in velocity divided by our d column, change in time. So we're going to skip those first two rows again. So now we have -7 divided by our change in time, which is 0.03. Okay, and then I'll do one more for you. This one is 59.67, change in velocity, divided by 0.03. Okay, and then the last thing we want to do here is change from centimeters to meters, because that's just how gravity is done. Okay, so let's go ahead and do so how do you do that? Well, if there's 100 centimeters, if there is 100 centimeters in a meter, how are we going to go from centimeters to meter? Well, most of you figure out you divide by 100. So keep doing that, divide by 100. And then when you get all this done, I want you to do that, unpause the video, and here's what you should get. Okay? Make sure you've got all these. Finally, question 1 says take the average of the last column. Try it on your own, but you should come up with 11.79. If you take the average, you add up all the accelerations and divide by 8. You get 11.79. And then question 2 says take out the first frame and the last frame. Well, the first frame doesn't have anything in it. So if you take out this last frame, then and you took the average, you get about 9.68. Okay, so then finally what we did is to get the accepted value of G, I said we were really, really close, so I came back and told them, I don't know if I can find it now, it's been a little bit, so this is number 21. Let's see if I can find it. Sorry about that, I meant to have this up. Here it is, 9.8 meters per second squared. So we got really close. So that's how much gravity is going. And that is how you do the video motion analysis.